I'm going to launch a poll. So you should see it come up on your screen. And all I need you to do is to answer it, whatever you think the answer or answers are. And then I want you to hit submit for me.
Okay.
Now, one thing that we learned the other day, because remember, Zoom for some people is a learning process for sure. So realize that when the poll comes up, if you hit anything else on your screen, it's going to go away. So please be careful when you're trying to answer. If it's something where I think you need, you know, some time to work it out, or it's an actual problem, I'm probably going to give you some time to do that. Okay, I'm going to give you about 30 more seconds, and then I'm going to pull the poll down. I'm going to share it with you. Okay, anyone need more time, or are you okay? Okay, I'm going to share it with you. So this one says, this has an idea of what people answered. You could answer more than one thing on here, and that would be okay. This is based on what we've been talking about. How can you show a function? Table, mapping, graphing, numbers, and equation. So actually on this piece, the ones we've talked about so far are the first three. We've talked about tables, mapping, and graphing. We will eventually be able to talk about numbers and also equations as being able to show how you do functions. But so far we've talked about the first three, okay? Now, listen, these are no harm, no foul kinds of questions. I'm just trying to get an idea of what you know and what you don't. And I know some of you are just joining me, so don't freak out about that. Because as we go through this, you'll get a better handle of how to answer these.
So it was kind of a trick question in a sense.
It's kind of a question of what do you remember from last time? So I kind of expected maybe the first three answers. Some kids are going to go through and they might answer more, especially if there's somebody who has, some kids have taken this class before or came from another school where they were taking it. And some of their sequences and classes, like if you came from East Jackson, we're not all in the same sequence. So they might have actually already covered part of it and know that, okay? So what I'm going to start with right here is some idea of what functions are, and we're going to talk about how we determine if something is a function. And basically, if you're determining if something is a function, either it's going to be yes, it's a function, or no, it's not. Now, okay, Chris, let's stay talking on math, okay? Because you're even distracting me here, kid. And I do not need any help. I appreciate your involvement. Be involved with what I'm doing, will you? Thank you very much. I'm going to do a lot of flow charts. That tends to work for me. So on here, I'm going to do some flow charts to be able to show you how to tell yes, it is, or no, it's not. So let's start first of all with yes. So if it's a function and we know that yes, it's a function, that means that every x matches only one y value. Now, in math terms, we would say that that means that it is perfectly predictable. Okay, so let's talk about this in terms of the real world. So if I was going to go to, oh my gosh, back to the days where we could actually go to movies. If you've ever been to a drive-in movie, there are some days that they have that no matter how many people are in your car, it may be $10 to go to a drive-in movie. So that means if you have 2 people, it would cost $10. If there were 4 people in your car, it would cost $10. If there were 6 people in your car, it would be $10. Now, as far as a real life example, is that one that is perfectly predictable? No matter how many people go in, it's going to be $10, right? So
Yeah.
when we talked about mapping the other day, if I added these ovals, that's an idea of one that is perfectly predictable, though. That's a real life situation. Now, in this one, the y value gets repeated, but that's kind of okay because every one of these x's only matches with 10. This x that's 4 would only match with 10. This x that's 2 would only match with 10. Okay? Let me give you one more example. So let's say instead of a drive-in movie, we're talking about going to an actual theater movie. Back in the days when we could actually be more than, 3 inches from each other. So when we went through this, if one person went to the movies, let's say it cost them $5. So if 2 people went, it would be 10. If 3 people went, it would be 15. Is it still pretty predictable? Okay, how much is it a person? Okay, you're right. So it'd be $5. So for 2 people, it's 10. For 3, it's 15. For any number that's not up there, could I still figure out what it is by multiplying it by 5? I could do that. Now, let's add our mapping pieces like we did the other day. That's an example of another one that is perfectly predictable. Okay, first of all, for the real life example back here, does that kind of make sense? The drive-in theater where everybody's $10 to get in. This one being $5 a person. Okay, so the good news about a function is it has this perfectly predictable kind of relationship. Okay, is everybody good with that part about the yes? May I move to the no? Does anybody need any time or is that okay? Okay, thank you. Okay, so if I go to no, here's what no tells me. No means that every x does not match only one y. Now, in our language, we're going to say this is not perfectly predictable. Now, the whole big idea with math is really just about being able to see the pattern and knowing if you can predict what's going to happen next. Because if you can find the pattern and predict it, then you're going to do pretty good at being able to do these problems because you'll have an idea, a process of what you're supposed to follow. So let me give you an example. So I'm taking tickets at a movie theater. So one of my friends comes in and when I'm talking about charging them, I'm like, oh, I like you. I'm only going to charge you $2. And we'll keep practicing these. So once we get the patterns, as I said the other day, I'm not going to go really fast on these. We're going to see some examples together. We're going to practice together, and then I'm going to give you something to do on your own. So you will not have to go off and do these where you feel like I'm Russian. That's not the way this is going to work. Okay, I promise. Okay, let's say that the next person comes into the movie theater and like we're friends, but like not really. So when they come in, this one person, I charge them $4 to get in. Okay, now the next person comes in and I really, really don't like them. So when they come in, I say their ticket's $10. Okay, first of all, the only thing that I can predict is I'm charging them some random price based on whether I like them or not, or whether we're friends or not. But if I look at this, no matter what one person comes in, I don't know what I'm going to charge them. See how it's very unpredictable? So if you were watching this, if you didn't know what was going on in my head, you'd have no idea why I was charging them this money. And even the next time I could have somebody come in and charge them something completely different than even these two. So if I added the ovals, like the mapping stuff we were doing before, this would not be a function because there's no way to predict what happens. It's no longer like the tickets are $5 a piece or a carload is $10 a piece. They're all different. Okay, so being able to do this is really what we're looking for. So let me just point this out. This X value is the one that gets repeated. That's the big no-no. So when they're talking about not a function, no X values. Now remember, in our mapping, the first oval that I have here is supposed to be X, and the second one is Y. So no X values can repeat. Or it's not a function. Okay, now this is what I would like for us to be able to do today. In the last part of class, what I want to do is I want to give you some examples that look different than mapping. And we're going to start to talk about whether we think they're functions or not. Okay, everybody with me on this? Okay, anybody have questions right now about what I've done so far or anything you want to ask on the yes or no part? Thanks, Chris. Anybody else for the good of the cause? Before I move down, I want to give you some examples here. Thank you. Okay, so as we go, I'm just going to call these examples. So this is going to be example 1. And the only thing that I am going to ask you is to determine if there's a function or not. Okay, so is it a function? And I'm going to use the same directions for all of these. Okay, hang on. Somebody's trying to come in and they're not. I'm just going to let them in because I want to tell them they're next hour. Miss Rhodes, can you hear me? Trying to see if she can hear me. Okay, here's the example I'm going to give you. 2, 4, 3, 6, 4, 8, and 5, 10. And we're going to talk about how you can determine if it's a function or not. Miss Rhodes, can you hear me? Maybe not. Okay. So if I'm looking at these, does everybody agree? This part's my X value and that part's my Y. So let's do what we were looking at before. Let's make a mapping. So I'm going to take these values right here and I'm going to put them in order from smallest to biggest. And hey, did I already do that kind of for you? That's the smallest value for X and this is the biggest. So that's going to go in my first oval. I'm going to take these numbers that are my y's. I'm going to put them in the second oval right here, and I'm going to put them in order from smallest to biggest. So 4, 6, 8, and 10. And there's my second oval. So let's go back to what we talked about on Monday. To be able to make these mappings, we actually take the X value and draw an arrow to the Y value it matches. So I would draw one that looks like this. So it's basically drawing a line, but the arrow's only at the end by where the Y's are. Remember, these are the Y's and these are the X values. That's how we set them up before. So 3 matches with 6, 4 with 8, and 5 with 10. So does every one X only match up with one Y? Okay, so this 2 only matches with 4. This 3 only matches with 6. 4 matches with 8, okay, and 5 with 10. Thank you, those of you who are responding to me in the chat. I appreciate you. So you can see it's perfectly predictable. So if I say the X value is 4, you know it has to match up with the 8. Okay, so remember, if I can tell that it is perfectly predictable, if I could spell today, then I know it is a function. So when we're doing these, our best chance at being able to answer these is to be able and take that so that you can see if it kind of maps out. And I would say the mapping that we're doing right here is usually the easiest way to see it. Now, can I show you what that would look like if I were to graph? Okay, can we just make a sketch on here? So I'm just going to do an X and a Y axis here. And I'm going to make 5 little tick marks on each one. Now, I'm going to try to keep them about the same amount away from each other, but I'm not worried that it's perfect. I just did 5 little tick marks on the X and on the Y. Now, if I were to go through and put numbers on here, if I look here, don't my numbers just go from 2 to 5 on the X? That's all they do, right? So I'm going to count up to 5, the biggest number there. Now with these points, the highest number is 10. So watch what I'm going to do here. 2, 4, 6, 8, 10. I just want to use those little 5 marks to give me enough room to be able to get all of those values on there. Okay, you hanging in there so far? Okay. That once we get this drawn, I think you'll see what I mean. I'm going to go right now and I'm going to graph these 4 points on here. Remember, it's just a sketch. So the first one's 2, 4. So I go over 2 and up 4 to make a point. 3, 6. 4, 8. 5, and 10. So if I'm looking at this, first of all, tell me something you notice about my 4 points. Somebody unmute themselves and tell me something you know, or drop it in the chat.
They line up.
Okay, they line up. Okay. Are they all single points? There's no line anywhere, right? Do you agree with me on that? Okay.
Mhm.
So if you're looking at this, it would be easy to tell by looking at the graph that every X only matches with one Y. There's not more than one line right here. Imagine if I took my highlighter and just did random vertical lines where those points are. Do you notice how there's only one point on each one of those little highlighting marks I did? So you're kind of imagining in your head what that looks like. So that's another way to show that something is a function. So what I've showed you right here are 4 points that are written as ordered pairs, written as mapping, and written as graphing to be able to show that something is a function. Okay, so here's the deal. I want to show you something real quick on Google Classroom, and tomorrow can we practice some non-functions before we do some practice on our own? And again, if you are somebody who just joined my class today from Mrs. Page's class, if you are somebody that would like a notebook, will you drop a message privately into the chat with me, or you are welcome to email me and tell me, okay? But I want to make sure everybody has a notebook, so as we're doing stuff together, you can just keep it all right in order, okay? In Google Classroom, okay. So in Google Classroom, first of all, those of you who did the assignment on Tuesday, can I just tell you how much I appreciate you right now? I was gone because my mother was ill. And actually my mother passed away on Tuesday. So I was glad I was able to be there with her. So thank you for those of you who took care of that for me. I very much appreciate you. If you did not get a chance on Tuesday to do that assignment in classwork on Tuesday, December 1st, that is, thank you, Carmen. I appreciate that. There was an activity that said Tuesday, December 1st. And it's a link, it goes to Desmos, it's just an activity builder. So if it's something that you haven't done, will you please take care of that for me today? Okay, if you haven't. You'll notice for today, it says for Thursday, December 3rd, all it says is live instruction on determination of functions, bring your notebook. If you are here with me right now, you can mark that turned in. I am gonna give you points just for attending today. I will tell you, you are going to shoot yourself in the foot, though, kind of as a figure of speech, I guess, if you're not taking notes, because you won't have stuff to look back on. And we will have an exam at the end of this class. So I want to make sure that you have what you need. So make sure, thank you guys. You guys are being so nice to me. Make sure if you aren't taking notes that you start today, okay? Because I don't want you to be left behind, and I don't want you to feel like, geez, I wish I had something that I don't. Okay? Anybody else have questions for the good of the cause here? Thank you. I will tell you this, guys. Did anybody notice that I'm recording this? Do you see a little record button on your screen? You might see my little red one at the top here. I'm trying to, okay, good. I can see it on mine. I just want to make sure you can see it. I am trying to record one class a day. But remember, you're not going to get a lot of videos. So please make sure that you're here, okay? And again, anybody else who needs a notebook, I did get the one who messaged me. I feel bad too, Carmen. I wish I could tell you how bad I feel. But if you do need a notebook, I will drop one off to you if you need one. In the next couple days, if you need something at home, okay? Okay, guys, so my plan is to see you back tomorrow. We're going to talk about what it means to not be a function. And once we go through that, then next week we can do some more practice with that. Okay? Those of you that switched over from Mrs. Page's class, welcome. There are normally 2 teachers in this class, but you're only probably going to see me until we go back in person. So again, any other questions, you let me know. Okay? Okay, bye guys. I'll see you tomorrow, same time, same place. Have a good day.